Tonight, we are going to go on a journey through time and space. A journey across the universe. But not literally, because we don't have the time or the budget for that. So I'm going to invite you all to join me on a bit of a thought experiment. And this thought experiment is going to require some mental gymnastics, a little dancing around topology in your head. So warm up your brains, give them a good stretch so you're ready to wrap them around the ideas that we're going to talk about today. What I'm going to do first is I'm going to take this strip of paper. I'm going to tape the ends of this strip of paper together. This shape, you'll notice, has two sides. There's an inside and an outside. And it also has two edges. There's this edge and there's this other edge. And notice that you can't get from one side to the other side without crossing a boundary, without crossing an edge. Plain, simple, nothing exciting about that one. We'll set that one aside. With just a few minor modifications, we get a much more interesting shape. This time, I'm going to introduce a half twist before taping the two ends together. Mathematics enthusiasts of all sorts will recognize this shape as a Mobius strip. And the Mobius strip, as many of you will know, only has one side. If you were to take your finger and trace along the surface of this strip, you could hit any point along this surface without having to cross a boundary. Similarly, it only actually has one edge. If you start on one side and trace around, you'll actually trace the entire edge without having to lift your finger. The Mobius strip is super interesting. Tons of fun, endless hours and hours of mathematical entertainment to be had. Grab the napkins off your table and try it out later. But this isn't what I'm here to show you. I promised you traveling through the universe. So now I'd like you to all take a moment to turn on your imagination, okay? Imagine that this strip is huge, like universe size huge. And you are tiny little creatures. Tiny little 2D creatures wandering around, lost on the surface of this little Mobius strip universe. If you start here, you could, in theory, wander all the way around the strip, and to you, you wouldn't have any clue what the shape of this strip was. To you, any particular region of this just looks like a flat plane. More formally in mathematics, we say that the curvature is locally flat. And so, wandering around, you wouldn't really have any sense of what the shape was, but if you so desired, you could make it all the way around to the side, to the point directly opposite where you started. Now remember, this isn't the other side, because a Mobius strip has how many sides? One. So you're not really going to the other side, you're going to a different spot on the same side, okay? This is important. Here's the mind-blowing part. We're gonna put a hole in it, okay? Now there's a hole in our Mobius strip. Imagine now that you are a 2D creature crawling through this hole. What have you really done? Well, Curtis, that's simple. I went to the other side, didn't I? But you didn't, because how many sides does a Mobius strip have? One. It's only got one side. So really, you've gone from one point on one side to a different point on the exact same side. Friends, I hold before you a trans-dimensional wormhole. And you may giggle, but it really is like traveling to a completely different point in your same world just by passing through this gap. Scale this up a dimension. There is no mathematical reason why we, as 3D beings, couldn't pass through holes in our 3D universe and end up in different points in our universe just because of how our universe is twisted and folded in 4D space. It's tricky to wrap your head around, but with nothing more than a piece of paper and a little bit of Scotch tape, you too can hold the secret to traveling the universe in the palm of your hand. Thanks, everybody.